In this video, we will be discussing about the logical operations. Logical operations in ARM assembly involve the manipulating bits within the registers. These operations are crucial for the tasks like bit masking, setting and clearing specific bits, and performing logical operations. Now, there are the five operations that store the result into a destination register, while these two logical operations do not store the result into a destination register. Else, they update the CPSR flags, which are the current state program status register. The AND operation performs the bitwise AND between the two operands. The OR operation performs a bitwise OR between the two operands. EOR performs a bitwise exclusive OR between two operands. BIC clears a specific bits in a first operand that we set in the second operand. MVN inverts all bits of the operand, which is similar to the NOT operation performed on the operand. The TST and TEQ in ARM assembly are used to perform bitwise comparisons between registers without storing a result. These store the result into CPSR. As I discussed, these flags can be used for the conditional branching and other conditional instructions. The TST performs the bitwise AND between the two operands, and the TEQ instruction performs the bitwise exclusive OR between two operands. Now let's see this more in the CPU later. Here I have already written the code that we will be discussing in this video. Here in the first two instructions I have loaded the value into a R1 and R2, where in the instructions from line 6 to 12 I have written all the other logical instructions. The values that I have already loaded are similar to this binary code. If you substitute 1 with F, you will be getting the similar code. Now in the AND operation, if you pass the 0 at the both values of A and B, you will be getting 0. Similar to if you pass 1 and another with a 0 value, you will be still getting 0. This is the truth table of AND, and this is the truth table of NAND, which is the NOT of the AND operation. And the NOT operation, this will reverse your inputs. In the OR operations, which will give you the 0 as a result if you are passing both the values 0, and 1 if either of the values is 1. But in the XOR operation, if the both of the values are same, the result will be 0. If both of the values are different, we will be getting the 1 as a result. Here, if you see in the AND operation, the both of the values are different. In this case, you will be getting 0 as a result. In the NAND operation, you will be getting 1, which will be all F's. And in the NOT operation of any single register, this will make the value to be turned. If you are passing this into a NAND operation, you will be getting this as a result. Well, if you pass this as the input into a NOT operation, you will be getting this as a result. In the OR operation, all this both inputs will give you the result as all ones. In the XOR operation, this will be giving the same result of the OR operation. Now let's compile and run. After loading the values into register R1 and R2, Let's make these hexadecimal. And after the AND operation, you should be getting all zeros into R3. And after the OR operation between R1 and R2, you will be getting all F's into the R4. Similar that was we discussed with the XOR operation. And in the BIC, what really happens is you will perform NOT operation on the R2 register, and that will the result, let's store that into R4, and the BIC will make the AND operation of R4 and R1. So this is how the BIC looks like. So if you perform NOT operation on R2, you will be getting R1, and if you perform AND operation between R4 and R1, you will be getting this same as R1. And if you step into R6, we should be containing the same value as R1. As you can see, the R6 contains the value of R1. And if you perform the NOT operation over the R1, you should be getting the value of R2. As you can see, this contains the value of R2. For the TST and TEQ instruction, let's first make this decimal sign. As you know, TST was the AND operation, and if you see the AND operation between R1 and R2, which was the 6th instruction, and the result was stored into R3, and it contains the value 0, which should be setting the 0 flag. And for the TEQ instruction, that was XOR operation, and the result was stored into R5. As you can see, the value is -1, and this should be setting the negative flag. So TST should be containing the 0 flag, and for the TEQ instruction, it should be containing a negative flag. Now if we jump over to the CPSR register and making it again hexadecimal, now you can see the CPSR flag and the corresponding flags. After the TST instruction, the 0 flag has been set, while after the TEQ instruction, negative flag has been set. So this was all about the logical operations.